In the year 1956, the Swedish engineer Sven Berge presented a project for a turretless tank to the military leadership, and everyone decided he had lost his mind. The generals laughed, the experts shook their heads. Foreign specialists called it a technical absurdity. A tank without a turret is self-propelled artillery, not a real main battle tank, they said. But 10 years later, this insane machine was in service with the Swedish Army, and 20 years later, British and American tankers were testing it and acknowledging it as revolutionary. How did one man manage to convince an entire country to build a tank that contradicted all the rules of tank construction? And why did this strange machine serve for 30 years, even though everyone predicted its failure? The Cold War was gaining momentum, and small neutral Sweden found itself in an extremely unpleasant situation. From the east hung the threat of the Soviet Union with its thousands of tanks, while the Swedes' own tank fleet looked depressing. In service were British Centurions, huge 3-meter giants that weighed 50 tons and barely accelerated to 35 kilometers per hour. These clumsy monsters were poorly suited for the defense of Swedish forests and lakes. A domestic tank was needed, adapted specifically for Swedish territory. In the early 1950s, the Ministry of War launched a program to develop a new heavy tank under the code name KRV, or Emil. The requirements sounded ambitious: a weight of about 30 tons with powerful armament, good protection, and high mobility. A consortium of the companies Landsverk, Volvo, and Bofors proposed a project with a huge 155mm gun and an oscillating turret. The project looked impressive on paper, but it had one problem: cost. The KRV program required colossal investments that small Sweden simply could not afford. In 1953, when the British unexpectedly agreed to sell Centurions directly, work on the KRV was formally frozen. But informally, discussions continued. The military understood that the Centurion was a temporary solution, not an answer to the long-term problems of Swedish defense. It was at this moment that Sven Berge entered the stage. This 40-year-old engineer worked at the Royal Army Administration for Ordnance, where he was engaged in the inspection of tank production. But Berge was not just a bureaucrat. He was a reserve officer in the armored troops. He drove tanks himself and understood their problems from the inside. Most importantly, Berge was fluent not only in Swedish and English but also in French, German, and Russian. This allowed him to study specialized literature on armored vehicles from all over the world, reading original technical reports and military studies. In the summer of 1956, Berge finished analyzing reports on tank losses in the Second World War and the Korean War. The statistics turned out to be shocking. The risk of being hit in battle depended directly on the height of the vehicle. Moreover, more than half of all tank losses occurred due to turret penetration. Berge came to a radical conclusion: any new tank must be as low as possible, and the simplest way to make a tank low is to remove the turret altogether. On October 22, 1956, Berge filed a patent application titled Notice of a Swedish Invention. The document described a technical solution for aiming the gun using the tracks of the tank itself. The idea looked insane. Instead of a rotating turret, the entire tank would turn on the spot for horizontal aiming, and for vertical aiming, a special suspension would be used that could raise and lower the entire hull. When Berge presented the basic concept in August 1956 to his department head, Höglund, and the head of the Vehicle Bureau, Eric Gilner, the reaction was restrainedly cold. A tank without a turret sounded like a step back into the 30s, toward assault guns and tank destroyers. But Berge was incredibly convincing in his presentation. He did not just propose removing the turret, he proposed an entire philosophy of tank building based on the analysis of real combat losses. Berge had studied the successes of tank destroyers in the Second World War. Sturmgeschütz and Jagdpanzers showed exceptional effectiveness in defense, thanks to their low silhouette and excellent maneuverability on short tracks. He also analyzed the French Char B1 with its precise transmission, which allowed for aiming the hull howitzer. Berge wanted to combine these advantages: low profile, excellent controllability, and precise aiming in one machine. But this required a fully automated transmission and a revolutionary suspension system. Despite the skepticism, Berge received permission to continue development. The military leadership understood that if the concept worked, Sweden would get a tank that would cost much less than traditional machines while having comparable combat effectiveness. In conditions of a limited budget, this sounded tempting. By 1957, the situation had changed. The KRV program had finally collapsed due to problems with weaponry, and the military began looking for alternatives. In the spring of that same year, work started in 3 directions simultaneously. The first direction, named Stridsvagn A, followed the British-American School of Tank Building, a machine weighing 42.5 tons, with a substantial silhouette and a power of 20 horsepower per ton. The second direction, Stridsvagn T, represented the Franco-German school, a light 32-ton tank with thin armor but high mobility of 30 to 35 horsepower per ton. And the third direction was Berge's concept, which received the name Stridsvagn IA, where S stood for Sverige, that is, Sweden. All 3 variants were to be armed with a 105mm gun, but only Variant S proposed abandoning the turret. For the military, this was an insane experiment. For Berge, it was a chance to prove he was right. To check the feasibility of the concept, Berge commissioned the Bofors company to create a prototype of the suspension and transmission system. Engineers took decommissioned American Sherman tanks and Swedish IKV 103 assault guns. They installed an experimental hydropneumatic suspension on them. The results exceeded expectations. The system worked. The suspension could precisely raise and lower the hull, ensuring the aiming of the gun vertically. For further tests, the system was installed on the chassis of the unfinished KRV project, removing 2 road wheels to bring the configuration closer to the future S tank. In 1958, the Swedish Parliament held a debate on which of the 3 alternatives to choose. The discussion was heated. Supporters of Variant A pointed to the proven design and reliability. Defenders of Variant T spoke of superior mobility, but Berge argued that only his turretless tank could combine low cost, excellent protection, and sufficient firepower for Swedish conditions. The decision was unexpected. Parliament chose Alternative S, despite the fact that it was the most expensive of the 3 variants. Why? Because this tank had symbolic significance. Sweden, a neutral country, wanted to show the whole world its industrial competence, to create a tank of a fundamentally new type, which no one else had. This was a matter of national prestige. The Bofors company received a contract to build 2 prototypes, which were named S1 and S2. Landsverk built the transmissions and Volvo assembled the engines. Prototype S1 received an electric motor as a power plant for suspension tests, and Prototype S2 was equipped with a unique hybrid power plant from Volvo, combining a diesel engine and a gas turbine. This was an absolutely innovative solution. No one had ever put a turbine on a serial tank before. In the autumn of 1958, Bofors presented the first conceptual drawings of the future tank. The machine looked like a low wedge, almost flat at the front. The length of the hull was almost the same as that of the Emil project, but the similarity ended there. The Stridsvagn S turned out to be 70 centimeters wider and 40 centimeters higher. The calculated mass was 31 tons. The engine and transmission compartment was placed at the front, another non-standard solution. The power plant was to be combined, a 300 horsepower diesel for normal movement and a 200 to 300 horsepower gas turbine for high speeds and difficult terrain. The armament also turned out to be unusual. The gun, rigidly fixed in the hull, was equipped with an autoloader that was fed from an ammunition rack in the rear of the machine. This meant that the crew could be reduced to 2 or even 1 person. No loader was required. But how many people were really needed to operate this machine, and what problems were discovered during the first tests of the prototypes? On January 3, 1961, Berge received American patent number 2,968,828 for his active suspension. By this time, the military had finally approved the Stridsvagn S as the main direction of Swedish tank building. However, Variant A was not completely rejected. Bofors continued to work on both projects in parallel for some time. The first prototype, S1, turned into a demonstration stand for the suspension. Instead of the standard engine, an electric motor was installed, and the British 105mm L7 gun was used as weaponry. The most interesting thing is that this is the only tank from the Stridsvagn S family that received a turret. Yes, a small turret with a 20mm automatic cannon was temporarily placed on the turretless tank. True, to maintain secrecy, the hull was covered with sheet metal so that no one could discern the real construction. Work was in full swing. The Swedes were developing the armament and power plant in parallel with the tank itself. The experimental machines were supposed to receive a 6.4-liter Rolls-Royce B81 diesel with a power of 230 horsepower. However, in mid-January 1961, a decision was made that the Zero Series tanks, starting with the third machine, would receive other engines. The Swedes already knew then that the turbine from Boeing would be weak, but the military would learn about this only after the start of serial production. In 1960, the Army ordered 10 pre-series machines. These tanks arrived for testing in 1963. Military tankers began testing the unseen design and immediately encountered a problem. 2 crew members could operate the tank and fire, but technical maintenance, guard duty, and reloading ammunition required more people. The solution turned out to be unusual. They added a third crew member and seated him facing backward. This radio operator driver was located in the rear of the tank with his back to the direction of travel, with a full set of controls. What for? So that the tank could retreat at maximum speed in reverse, always keeping its frontal armor toward the enemy. The rear driver simply took over control, and backward movement became forward movement for him. In the spring of 1963, the tank was shown to the public for the first time. A world sensation. Even U.S. President John Kennedy expressed interest in the design. Secretary of Defense Robert McNamara wrote a memo noting the advantage of the Swedish tank over the American M60 in its low silhouette, lower weight, and amphibious capability. The Americans were forced to admit, small, neutral Sweden had created something revolutionary. For armament, the British 105mm Royal Ordnance L7 gun was chosen. The gun passed through the entire tank, and the casings were automatically ejected through the rear part. The autoloader worked at an incredible speed, 3 seconds between shots. This meant 15 shots per minute, surpassing most tanks with manual loading. The autoloader was fed from 2 magazines, one for 25 armor-piercing shells, the other for 20 high-explosive shells. In 1971, the armor was tested by shelling. Armor-piercing shells with a velocity of 1,308 meters per second had only a 50% chance of penetrating the sloped armor, although the thickness of the frontal plate was only 40 millimeters. The secret was in the angle of inclination, 78 degrees from the vertical. The effective thickness increased many times over. The tank received the designation Stridsvagn 103. The height was only 2 meters and 14 centimeters against 3 meters for Swedish Centurions. The suspension allowed the hull to be lowered by another 13 centimeters. Behind the crest of a hill, the tank practically disappeared from view. Under the nose was a dozer blade for rapid entrenching. The most radical feature was the power plant. 2 different engines worked jointly. A Rolls-Royce K60 diesel with 240 horsepower for normal movement and a Boeing 502 gas turbine with 300 horsepower for high speeds. The Stridsvagn 103 became the first serial tank in the world with a gas turbine engine. The Soviet T-80 and the American Abrams would appear only many years later. The tank became fully amphibious in 25 minutes by deploying a collapsible flotation screen. The tracks propelled the machine through the water at a speed of 6.5 kilometers per hour. In the autumn of 1964, the Army ordered 70 serial machines. The first Stridsvagn 103A tanks arrived in 1967, and here it turned out. The 300-horsepower Boeing turbine was hopelessly weak. The specific power was only 14.3 horsepower per ton instead of the planned 18. In 1970, production of version B began with a Caterpillar turbine of 490 horsepower. The total power reached 730 horsepower. All previous tanks were modernized to this standard. By the end of 1971, 290 tanks had been built. And now, the most interesting part. How did the crews react to this strange machine? In 1967, Norway compared the Stridsvagn 103 with the German Leopard 1. With hatches closed, the Swedish tank detected more targets and fired faster. In 1968, the British Tank School at Bovington tested the machine for 6 months and acknowledged that the turretless concept had significant advantages. The British, creators of legendary tanks, praised the radically new design. In 1973, the British Army of the Rhine conducted maneuvers with the Stridsvagn 103. Technical readiness never dropped below 90%. The final report stated, it was not possible to prove any disadvantage in the inability to fire on the move. In 1975, the Americans tested the tank at Fort Knox. The Stridsvagn 103 shot more accurately than the American M60, although slower by only half a second. Critics insisted that the tank was suitable only for defense, but the Swedish doctrine was aggressive. Brigades with the Stridsvagn 103 were called assault brigades. Their task was counterattacks against landings. The low profile was for protecting the crew during an attack, not for passive defense. All 3 crew members could drive and shoot. Even after losing 2 people, the tank remained combat capable, a unique feature. By the 70s of the 20th century, the Stridsvagn 103 had proven its value. In the 80s, modernization to version C began. A new Detroit diesel, laser rangefinder, improved fire system. But what happened next with this strange tank, and why was it eventually abandoned? But the Stridsvagn 103 had one more secret feature, which the world learned about only in 1992. A special slat armor was mounted on the frontal part of the tank, a metal mesh at a distance from the main hull. This protection was kept in the strictest secrecy and was planned to be installed only in the event of a real war. Why such secrecy? The grill was intended for the premature detonation of shaped charge shells and anti-tank missiles. When ammunition with a shaped charge warhead hit the grill, it either exploded prematurely at a distance from the real armor, or the fuse was damaged and the shell did not detonate at all. Tests showed high effectiveness against anti-tank missiles and recoilless guns of the 70s of the 20th century. The cumulative jet, passing a meter or a meter and a half through the air after a premature explosion, lost a significant part of its penetrating ability. Additional protection was provided by jerrycans with fuel placed along the sides, starting with version C. They served simultaneously as additional tanks and as an anti-shaped charge screen. The Swedes thought out the protection of the smallest details. By the 80s of the 20th century, a problem appeared. Soviet tanks received new shells. 125mm subcaliber shells of the T-72 tank pierced the frontal armor of the Stridsvagn 103 through and through, from the front part to the engine compartment. The Swedes understood this perfectly well. In 1980, the Army demanded that all tanks be written off and replaced with the new Stridsvagn 2000. But in 1982, the government cut the military budget and, instead of new tanks, ordered the modernization of old ones. They began developing version D, the most ambitious modernization. They planned to install a new gas turbine, a system of protection against weapons of mass destruction, thermal imagers for the gunner and commander, an improved ballistic computer, a gun reference system, improved suspension damping, additional frontal armor, and even an independent stabilizer for the commander's machine gun. One prototype of the Stridsvagn 103D was built, but the matter did not go further, because in the late 80s of the 20th century, the unexpected happened. The Cold War ended. The Soviet Union collapsed. The threat of invasion disappeared. Military budgets were sharply reduced. The Stridsvagn 2000 program was canceled. The Swedes needed new tanks, but developing their own became economically inexpedient. In 1991, it was decided to purchase foreign machines. A tender was announced in which 3 tanks participated: the American M1A2 Abrams, the improved German Leopard 2, and the French prototype Leclerc. The tests ended with the victory of the Leopard 2. The American Abrams took second place, and the Leclerc dropped out partly because it was still in the development stage. In 1994, Sweden leased 160 obsolete Leopard 2 A4 tanks from Germany under the designation Stridsvagn 121, while waiting for the delivery of new Leopard 2 A5 tanks, which would become the Stridsvagn 122. But before riding off the old Stridsvagn 103, the military decided to conduct one last experiment. In the late 90s of the 20th century, military exercises were organized at the training ground in Kvarn. 7 Stridsvagn 103 tanks took up defensive positions against 7 brand-new German Leopard 2 A4 tanks, Stridsvagn 121. The result was stunning. The 30-year-old turretless tanks, which everyone considered obsolete, destroyed all 7 modern Leopards, losing only one machine. The low silhouette, the high rate of fire of the autoloader, the ability to quickly occupy and leave firing positions in reverse, all these features gave the old design a decisive advantage in defensive combat. The tank, without a turret, which people laughed at 40 years ago, crushed the best main battle tank in Europe of that time. But this was the swan song of the Stridsvagn 103. The year 1997 was the last for this tank. It was written off not because it fought poorly, it never participated in real combat actions. The reason was more prosaic. Modern tanks possessed thermal imagers, computerized fire control systems, and the ability to conduct precise fire on the move. The Stridsvagn 103, with its 105mm gun and analog instruments, was simply technologically outdated. 30 years of service is an excellent result for any tank, and for such an unusual design, it is a real achievement. The history of the Stridsvagn 103 is unique. Engineer Sven Berge proposed an insane idea, a tank without a turret, and managed to convince an entire country to build 290 of such machines. Everyone predicted failure, but the tank turned out to be so successful that it served for 3 decades, and in the final duel defeated its successor. So, what is the secret? Why did this strange machine prove viable, although no one else in the world dared to repeat the Swedish experiment? The answer lies in the specifics of Swedish defense. Sweden did not intend to fight in the deserts of the Middle East or on the plains of Central Europe. The Swedish theater of military operations consists of forests, hills, and lakes. Here, what is important is not the ability to fire at maximum speed while pursuing the enemy, but the ability to quickly occupy an advantageous position, strike a precise blow, and retreat. For such conditions, the low silhouette, high rate of fire, and the possibility of rapid retreat in reverse proved more important than a rotating turret. The Stridsvagn 103 became the first serial tank with a gas turbine engine, opening the way for the Soviet T-80 and the American Abrams. Its hydro-pneumatic suspension for aiming the gun inspired the creators of other machines. The concept of auto-loading and reduced crew also received further development. The tank, which everyone considered an evolutionary dead end, actually anticipated many technological solutions of the future. Today, several Stridsvagn 103 tanks are kept in the Swedish Tank Museum arsenal. All are in working condition. Among them is the only prototype of version D, evidence of what the modernization could have been if the Cold War had not ended. These machines remind us of a time when a small neutral country challenged all the canons of tank building and won. Sven Berge proved that sometimes the most insane ideas turn out to be the most enduring.